Hello and welcome to another video in our series of videos about ABES, Geometry Control Software. My name is Martin, and in this video clip I would like to talk about longline casting. The advantages of performing a detailed geometry control procedure throughout longline casting may not be quite as obvious as it is for shortline casting. But these advantages include improved quality control throughout the erection process. It includes the detection of possible systemic errors. And perhaps most importantly, the main advantage would be that if one knows the exact geometry of each segment, one can then use this knowledge on the construction site, at the construction site, during the erection of the bridge. With all this in mind, I would like to introduce the example that we are going to use during this video. It's a straight piece of bridge with a base segment right here in the middle and a construction sequence out on each side of this base segment. I will show the longline casting of this portion of the bridge, and here is what I've already set up. In the casting yard, I've set up a mold and a secondary bulkhead. The mold is designated as a longline mold using this tick box here. It's placed at a certain position in the casting yard with the primary bulkhead on the left side and 3 control points on the primary bulkhead. I've also set the visualization to 9 meters on each side and a 20-meter length, just to have some values in here and to see something on the screen. Perhaps it's one thing to note here is that the 3 points on the bulkhead are not located in one line. There is one point in the middle that's 300 millimeters higher than the 2 points on each side. So BM here in the middle is elevated in relation to B1 and B2. If that's not possible, and sometimes it is, and the 3 points need to be placed in one line, that introduces a geometry inconsistency for the program. And in this case, it helps to set glob Z, the glob Z flag here, which means that the program will always assume a perfectly vertical joint here. Preferably, we don't have to do that, and I'm setting it up in this way, so the verticality of the joint will be determined by surveying these 3 points here. I have also defined a secondary bulkhead and I will use a similar logic for my control points here. The middle control point is elevated, and I will do away with the glob Z option here for the very same reasons. Now, in our longline casting bed, the primary bulkhead is the one that moves out along the casting bed as we progress in our longline procedure, and I will keep the secondary bulkhead at the start of our casting sequence, mostly for optical purposes or visualization purposes in our software. This is already the mold definition dialog, and we are going to choose our longline mold for the casting, and we are using the secondary bulkhead that we've just seen as our secondary bulkhead. And because obviously there is a crossfall here, we are going to turn the surface of our segments to horizontal. The Z's are now both 0, and I'm assuming that this crossfold rotation translation menu up here is known to my viewers here. And we also need to rotate the secondary bulkhead so it fits with the rotation and the translation. And as we can see, we are now perfectly horizontal in our segment, and our bulkhead, our secondary bulkhead at the start of the casting bed is also aligned as expected. We accept that. And this is now how our first segment is located in our casting bed. This is the base segment here. It's partitioned into two subsegments, so this will be the axis of the bearing axis. We have our primary bulkhead here, and we have our secondary bulkhead here down this side. As we continue with subsequent segments, we will see that this secondary bulkhead, it will remain in this location, but the primary bulkhead will be moving out, and it will drag the visualization of our casting bed with it. If we go and review the casting sheet, we can see that geoCon provides us with the setting out locations of our primary bulkhead and the secondary bulkhead. As we can see, these are the three control points, and these are the locations that we have selected or that the program has calculated for the setting out. And we also get, as per usual, the intended locations for our control points in the newly cast segment. Clicking on next, we get a last opportunity to update our bulkhead locations in case something has moved, and if that's not the case, we move on, cast our segment, and we can now input the survey data from our newly cast segment. Let's assume that everything has been done perfectly. Our bulkhead, secondary bulkhead is here, our primary bulkhead has not moved, and these are the locations for our new control point markers. I'm setting this to ideal, so I am assuming a perfectly cast segment. Accept. Okay, and here we are. This is our new segment, and in the global view, our new segment is shown in green, meaning that this is now cast in concrete. The next segment to be done is the segment here shown in blue, and we proceed by clicking next in order to set it out. This input screen here is the setting out data. It looks very similar to what users are used to from short-line casting, except up here we have still selected our mold, our long line mold. The rotation here is still the same, and we have our new segment with the intended control point locations, and we have the position of the last segment in our sequence, the conjugate segment. We can accept that, and in checking our casting sheet again, we can see that we are getting an updated location now for our bulkhead, and that's something that's unique for the long line casting procedure in this program. The program has moved the bulkhead to the next intended location. Everything else looks very much like a short line casting sheet with the match cast segment and the conjugate segment control points listed here. That's the setting out data, and this is where we will be filling in our survey data on site. Next step allows for a final survey of our mold, and let's say in this case, something has happened and our primary bulkhead has moved. So what we would do is we would, choose the fit option. We are fitting to our mold control points. Our mold control points, this is how we said they would be positioned. And this is how we surveyed them. And I will simply introduce a twist in here. So it's moved forward on one side and backward on the other side. And in fitting this, the program now calculates our new primary bulkhead positions. And we can already see what's been done. This is the primary bulkhead now. And as the mold is associated with the bulkhead, the program now assumes the whole mold has been turned around like this, and our existing segment sits here. Now, obviously, that can't be the case, and we'll have to survey our data. But what we have told the program is that our bulkhead has moved. We can accept that. Next. The program now is now asking for the survey data for our conjugate segment control points. This is the last segment that's sitting in the mold, and the survey data for the control point markers in the new segment. And this time I can't click on set ideal because we have already seen the program thinks that the whole setup has twisted, but in reality only the bulkhead has twisted and the conjugate segment has stayed where it is. So I'll quickly fill in the realistic survey data which we would receive from our surveyor on the construction site. This is our survey data, unquote. I've obviously saved some data in an Excel sheet to use for this purpose. However, we can see that our conjugate segment has not moved from its original position, and only the bulkhead side has changed, and our control points there are somewhat different than what the program would have expected. And on the conjugate side, our control point markers are where they would have been placed anyway. Accept that. And let's switch off the casting curve and setting out. We can already see what has happened. Our bulkhead has turned ever so slightly, and we have produced a casting error in our longline bed. Now, I have charged ahead now, and I've followed the prompts of the program and assumed a perfect cast of the next segment. And this visualizes how the program has now corrected our error in this second segment here. So, in essence, this is how longline casting works. And in the casting yard view, this is how it looks. This is our longline casting bed, and it's moved out from its original position all the way to here. And if we continued along the same lines, this would be moving out further and further until we finish our casting sequence. I hope that this is a good overview, and we will see this function used in many projects.